And welcome back to this channel. In this series, we are going to be looking at data structures in computer science. As software engineers or computer scientists, we deal with data a lot. Therefore, understanding how to store this data and how to organize this data so that it can be used effectively must be our top priority. In this series, we will pick each data structure and we are going to discuss it in detail. The purpose of this first video is to give us an introduction to the series. Data structure contains two words, which are data and structure. What is data? In computing, data is a collection of facts which can be numbers, words, measurements, or observations that have been translated into a form that computers can process. So in summary, data is a fact that is in the format that computers can process. For example, we have 10, which is an integer, Ronald, which is the combination of alphabets to form a word, and we have true. However, at the very basic level, data is stored in form of zeros and ones in memory, also called binary. What is a structure? A structure is an arrangement and organization of interrelated elements in a material object or system. This is the general definition of a structure according to Wikipedia. Now that we know the definition of data and the definition of a structure, let's look at what a data structure is. So what is a data structure? Data structure is a way to store and organize data so that it can be used effectively. Pay attention to the word effectively, because the way you organize and store your data plays a large role in how effective the data can be used. For example, if we have an online store where they sell wristwatches, let's assume today's date is September 24, and a customer comes requesting the latest wristwatch. Most likely, the latest wristwatch will be the wristwatch that was added on September 24. If I ask you to find the wristwatch that was added to the catalog on September 24, can you find it? I will give you some seconds for that. Okay, so the marked wristwatch is the latest. However, it took you some time before you could find this wristwatch. Is there a way we can arrange this product such that the latest product will be seen first? This is the new arrangement. With this arrangement, the latest product will be the first item in the catalog. So when the user comes requesting the latest wristwatch, it is the first item in the catalog. This will not make him or her spend much time looking for the latest product among other products. When a new product comes in, it is added to the front of the catalog. From this example, we can see that how we arrange and organize our data plays a large role in how effective it can be used. Types of data structure in computer science. There are two major types of data structure in computer science, which are the primitive data structure and the non-primitive data structure. Now, we will look into this in more detail. What is a primitive data structure? A primitive data structure is a kind of data structure that stores data of only one type. Basically, a primitive data structure stores one value of only one type. Characteristics of primitive data structures. The first one is that it cannot be broken down into simpler data structures. So we can say that the primitive data structures are the basic data structures that we have in a programming language. Also, the primitive data structures are specific to the programming language that is being used. What this means is that the programming language being used has inbuilt primitive data structures which will be used. And these data structures might not exist in other programming languages. So, for example, the character keyword used to store a single character in C++ does not exist in another language like JavaScript. Examples of primitive data structures. A Boolean. A Boolean stores a value that is either true or false. We have an integer. The integer stores a positive or negative mathematical integer. For example, we have 1, 2, and 3. The next one is the floating point. The floating point primitive data structure stores a number as a whole plus fractional digits. So basically, any number expressed in the form of a decimal can be stored as a floating point. The next one is a fixed point. A fixed point primitive data structure stores a number that has a specific number of bits or digits reserved for the integer part and a specific number of bits or digits reserved for the fractional part. When you look at a decimal number, there is the whole number side, which is the left side to the decimal point, and there is the decimal number side, which is at the right side to the decimal point. So you can specify the number of digits you want at the whole number side and the number of digits that you want at the decimal number side. In this example, we have 4 digits at the whole number side, which is the left side, and we have 3 digits at the right side, which is for the decimal. A character. A character stores a single character, which can be an alphabet or any other character. For example, we have A, B, and C. The next one is a pointer. A pointer stores a reference to a value that points to another value. When you assign a value to a variable, it stores it at a location in memory. So we can say that a pointer stores the address of the location where a value is stored in memory. The next one is a string. A string stores an array of characters. Basically, the combination of characters can be referred to as a string. Now we move to the non-primitive data structure. A non-primitive data structure is a type of data structure that can store data of more than one type. For example, in a hash table, an entry has a key and a value. So let's assume we have a key of name and we have a key of age. The key name will store a value of type string, whereas the key age will store a value of type integer. An example is shown below. Characteristics of non-primitive data structures. A non-primitive data structure can be linear or non-linear. Linear means the data are sequential, or in other words, they are sequentially arranged, whereas non-linear means the data are non-sequential. A very good example of a linear data structure is an array, and a very good example of non-linear data structure is a binary search tree, and the diagrams are shown here. A non-primitive data structure can be homogeneous or heterogeneous. Homogeneous means the data structure stores data of the same type. For example, we have 1, 2, 3, 4, 5, which are all integers. Heterogeneous, on the other hand, means the data structure stores data of different types. For example, we have 1, which is an integer. We have ball, which is a string. We have false, which is a boolean. And we have 0, which is an integer. So you can see that this array is storing data of different types. A non-primitive data structure can also be static or dynamic. Being static means the data structure has a fixed size, structure, or memory location in compile time. So once any of these has been predefined, it cannot change. A non-primitive data structure can also be dynamic. In this case, the size, structure, or memory location can shrink or expand according to the use of the data structure. That is, once the threshold is reached, we can expand the size of the data structure. A very good example of a dynamic data structure is the dynamic array. Data structure versus abstract data types. Most times, these two concepts are confused together. Let's look into this in more detail and see the difference or differences between them. The abstract data type is a type of object whose behavior is defined by a set of values and a set of operations. Note that the abstract data type only mentions what operations are to be performed, but not how those operations will be implemented. An abstract data type only tells you the set of values and set of operations that define the behavior of an object, but it doesn't tell you how the object actually implements those operations. Let's take, for example, if we have a user that wants to move from point A to point B, what are the options that we have? He can move by car, he can move by bicycle, and he can move by bus. So in this example, an abstract data type only tells you that a user moves from point A to point B, while a data structure will explain how it achieved it, which can be by car, bicycle, or bus. We can see that a data structure provides more information about how the user moves from point A to point B. Therefore, we can say that the abstract data type is like an abstraction over the data structure. This diagram shows the hierarchy of data structure. We will be looking at every data structure in this diagram, and I will teach you how you can implement them. Where and how they can be used will also be discussed in this series. You might want to download the slides and check out this diagram because we will be using it a lot in this series. Why do you need to know data structures? Number 1, don't just write an algorithm. Make it efficient and powerful. When you write an algorithm, it takes a particular space in memory and it consumes a particular amount of time. If you write an algorithm that takes too much time to run, or you write an algorithm that consumes too much space, that algorithm is not efficient. To write an efficient and powerful algorithm, you need to know the right data structures or data structure to use. Using data structures makes your code easier to read and understand. When you use data structures in your code, it makes your code cleaner and easier to read. Why? Because you can reuse a data structure in multiple places. Introducing data structure to your code brings about the concept of abstraction and reusability, which generally makes your code maintainable and readable. Understanding data structures improve your approach to problems and solutions. When you get to a technical interview setting, the interviewer will give you a question and you have to be able to model this question in form of a data structure. Let me give you an example. Let's say you get to an interview and the interviewer asks you to write an algorithm that assigns patients to doctors according to the level of their injury. What this means is that when a patient with a headache and a patient with a snake bite arrives at the same time, the patient with a snake bite will be attended to first because the snake bite case is worse than the headache case. You have to think of the data structure to use. And the first data structure that might come to your mind is a priority queue. We will look into this data structure in more detail in the future. Alright, thank you very much for staying till the end of this video. Don't forget to subscribe by clicking the red button so that you can be notified when the next video comes out. Feel free to like, comment, and share. And if there is any topic you want me to discuss on this channel, you can put it in the comment box. Thank you very much. See you in the next video. Bye.